Welcome to this video tutorial on implementing k-means clustering in Java. Today, we'll explore the theory behind clustering, dive deep into the k-means algorithm, and walk through a complete implementation. Before we dive into the code, let's discuss what clustering is. Clustering is a type of unsupervised learning that groups an unlabeled dataset into distinct categories. The k-means algorithm is one of the most popular clustering methods due to its simplicity and efficiency. In k-means clustering, k represents the number of clusters we want to partition our data into. The algorithm partitions the data based on the mean distances to the centroids of the clusters. The algorithm involves three main steps: initialization, assignment, and update. First, we randomly select k centroids. Then we assign each data point to the nearest centroid. Finally, we update the centroids by taking the average of the assigned points. Let's get started with our implementation. First, we need to set up our Java environment. Please ensure you have Java Development Kit, JDK, installed on your machine. We will also be using an IDE like IntelliJ IDEA or Eclipse to write our code. Now, let's create our main Java class for k-means clustering. I'll name this class k-means. Inside it, we'll define our data points and implement the k-means algorithm. Here, we defined a nested static class point to represent each data point with its coordinates and the assigned cluster. In the main method, we created a sample dataset consisting of 6 2D points. Next, let's implement the k-means algorithm. First, we'll need methods for initializing the centroids, assigning clusters, and updating centroids. In this method, we choose k random data points from our dataset as the initial centroids. This forms the basis of our clustering. Let's implement the method for assigning clusters to each data point based on the closest centroid. Here, we iterate through each point, calculate its distance to all the centroids, and assign it to the cluster of the closest centroid. Now we need a method to calculate the distance between 2 points. This distance metric will help the algorithm determine how close each point is to a centroid. Now that we have assigned clusters, let's implement the method for updating the centroids based on the current cluster assignments. The update method recalculates the centroids' positions based on the points assigned to each cluster. We'll also need a loop to run the algorithm iteratively until the clusters stabilize. In the k-means clustering method, we continuously assign clusters and update centroids until they no longer change, which means we have our final clusters. Now, let's visualize the results after clustering. This method prints out the points along with their assigned cluster. Let's tie everything together in our main method and run our k-means clustering implementation. Now give it a run. If everything is correct, you should see the output with data points and their assigned clusters printed in the console. Don't forget to adjust k based on the number of clusters you want. Remember, k-means is sensitive to initial centroid placement. To improve results, consider using methods like k-means++ for smarter initial centroid selection or running the algorithm multiple times. For larger datasets, k-means can be slow since it needs to re-evaluate all points multiple times. If you're working with big data, consider using libraries like Apache Spark or parallel computing solutions. That wraps up our tutorial on implementing k-means clustering in Java. I hope you found this walkthrough helpful. Understanding how k-means works will give you a solid foundation in clustering techniques. If you enjoyed the video, please give it a thumbs up, subscribe for more tutorials, and share your thoughts in the comments below. Happy coding!